And I again didn't have. I don't have this typed up yet. I'll try to get it typed up. But luckily, I was looking through and there's not many things you have to write. So, activity 1, 2, 3. I should have the previous one wrapped up. I should have had it due yesterday. I give y'all one extra day in case something happens. Alright. So, on this one, you're going to need to have to download. There's no copying and pasting because there's a hidden file here. There's a hidden file called Apple GIF. And to get it, you're going to have to hit download and extract the file and put it in a folder. You'll also have to rename main.py to this. But so far, you've achieved some interesting graphical results using Turtle. In this activity, you will expand your potential of your code by adding images to it and manipulating how the turtle appears. So we've gotten to where we can make our code interactive. We can ask the user for input, type into the terminal. We can click on turtles and cause it to do something. Now let's look at actually using the keyboard to move a turtle around. So you will practice your skills you gained working with lists and apply them to a typing game where apples fall from a tree whenever you type a letter that they display. So you'll need to download this to get the image. The image has to be in the same folder as the code in order for this to work. So here it tells you from your browser's downloads, right click in the zip file and select extract all. Don't use up and with. Extract the files to a new folder. They use the naming scheme 12/123 source, but you can use whatever folder naming scheme you've been using. Rename it. They just did apple_1. Rename it to A123_apple1. It really doesn't matter. Run main.py and visual. So if you wanted to just run your code using Visual Studio without actually hitting the green arrow, you can do this from any terminal. So you can come over here and type into the terminal Python and then give it the name of the file and it'll run it. So print hello. I don't know why I do that. I always put a W at the end of hello for some strange reason. I think it's because I always know world comes next. You can come to terminal and type it like this and it'll execute your code, or you can just come over here and click on the triangle, it does the same thing. So observe the source code. It defines draw apple function that takes an active apple as a parameter. At runtime, what type of object is apple? Active apple. So here's the function draw apple. It takes a single parameter called active apple, and we can trace back. So we look at where this function is called. It's called here. It receives a variable called apple. We come and look back over and see where apple was defined. Apple was defined here, and we can see that apple is a turtle object. So this function is passed in a turtle object. Therefore, this parameter is a turtle parameter, or a turtle object. Note also, what I would recommend getting and doing, you don't really need to do it with objects apparently, but I always like doing it anyway. You can put in global win to ensure that this is considered a global variable. Just to be on the safe side, make all your variables global. We can also see something different being happening. Screen is now added to the top top of the program instead of at the very end, because we use the screen object ahead of time. Also note that this has uses setup to change the width and the height. So let me come over here and do this. So download. All rename it this file A123 underscore apple underscore 1.py. Note, whenever you're renaming, if you don't see any file extensions, if you click rename on this, and you don't see any file extensions, it's hiding it. Don't put in another extension. Yeah. To ensure, you can come over here to view and now enable file extensions. And now if you enable file extensions, you would have to include the py. But if file extensions are temporarily off, you don't have to add it. Depends on how you have this set up. You can see also that there are multiple files included. This thumbs is just the thumbnail of the folder. These are the main 4 files. So let's run this code. I wish I could make the get started turn off. There should be a way of doing that. Now then, what do you think? So when I open this up, look how big this folder is, or this file is, or this window is. I mean, so what do you think this does? Set up with width equal to 1, height equal to 1. And when I opened it, it was very large. So again, when I run it, the screen changed to having a width that is what? The width is 100% the width of the screen, and the height is also 100% of the height. So let's come over here. So this is basically making it full screen. Let's instead do 0.5 and 0.5 and see how the screen size changes now. So let me put it in the corner. No, look at the width. The width is about a half. And look at the height right here. It's about half. Note that my 2 screens are different. So my computer monitor, it does half the width of my computer monitor and half the height of my computer monitor. The TV screen that I'm recording on is slightly different dimensions. But what this does, it sets it to some percentage of the screen size. So we can see here width. By default, it is 50% of the screen. Height, by default, is 75% of the screen. So that's the reason why y'all's turtle, whenever you create it on different screens, is different. Is because it does it based on the height of your monitor, which y'all's screen might be different than mine. It's actually a good idea to do things relative. So you can, if you want to make a full screen app, you need to define locations based not at certain pixels. So y'all been doing go to, and then you would say go to negative 150 by 0 or something to go get to the left edge. What you would want to do is extract the window size and tell it to go and do 0 pixels away from the left edge. That way, whenever you change the size or you do it on a different screen, it still looks correct, regardless of how big your window is. So it says modify your code so that appear image appears instead of an apple. So we come look, we can see peer GIF, background GIF, apple GIF. So in order to change it to a peer or pair, you can just change that. And we can see that the image is now doing a pear instead of an apple. You might notice there's a different one called background. We can go ahead and see what the background looks like. GIFs don't have to move. So GIF is an image. It just supports animation. So a GIF is actually a static image, but the technology behind GIF allows it to contain multiple images, and players or viewers can play all the images attached to it. It doesn't have to be animated. It's just JPEG is by default only contains one image. A GIF can have a collection of images and stored under one file name, and thus can be played as a video or animation. So, create a scene with a tree with an apple. So for your type of game, you will need a static tree image as the background, and will need an image, apple image to fall down. When you want to embed a stationary image as a background on your screen, the code is a little simpler. So you can use win.background image or background picture, and come over here. So let's change this back to Apple. We can come over here and add background image. There's a crash. Cannot open background. Notice, I love this. What's wrong with this? Do you see something wrong with it? What's this say? Does it say ground? Where's the G? So this is obviously wrong. There's supposed to be a G right there. Yep. And now we have an apple and we have a tree background. So there is an error. It says modify your code by defining and calling a function that causes the apple to move or move to the ground. The following functions may be helpful in terms of finding out where the turtle starts and determining how far it is to the ground. So again, if you want to get the x-coordinates of a turtle, xcor is the method. Because the apple is a turtle, by default it draws a line. If you have not already, modify your code so that the apple does not draw a line. So if we wanted to come over here, what we can do is right when we create apple, we can go ahead and call pen up because we don't want it to draw a line when we move it. We can also, depending on where, so since we're going to be drawing a lot of apples, it might make sense to add this here and change it to active apple. So that it, whatever turtle or turtle we pass in this function, it'll go ahead and set up, cause the pen to be moved up. So modify your code by defining a function that causes the apple to fall to the ground. So what's a good name for a function? That would make the apple fall to the ground. That's again hard to read. So drop apple. Drop apple is good. So this is going to take an active apple. So this function causes an apple to fall to the ground. Don't forget to be commenting your functions. So how would an apple drop to the ground? So we'll only be changing the y coordinate. So while active apple dot y coordinate is greater than ground. Nope. What we would do is active apple go to. So where do we want to make it move? So we want to change the y coordinate by 1. So we're not going to change the x coordinate, but then we would put in active apple dot y core minus 1. The what? Yeah, because go to takes an x and a y. This is one way of doing it. But notice ground is not defined. So let's make this a global variable. And I'm going to actually call it ground level, and let's make it 200. And then change this to ground level. Since this is a global variable, global ground level. And then let's come over here and call our function drop apple. And we see it do it. I got really lucky on this. Alright. So let's come over here and change it to maybe negative 180. And maybe negative 160. There we go. So this is one way of doing it. Another way we could have done it is maybe we could have. So this is one method. Let me comment it out. We could have done active apple dot set heading 90 degrees. Well, we don't know what. I mean, we kind of do know what direction it's moving, but while the coordinate is greater than ground direction, active apple dot forward 1. Let's see what this does. Oh, definitely not. That's an infinite loop. So what we want to do is negative 90. Negative 90. And look at her. It does the exact same thing. You really don't want to do turn left or turn right. The reason why is we do not know what direction is currently looking at when you pass it in. This is how we make code generic. We assume that whatever apple we pass into this is pointing in a random direction. Yes, you're right. We didn't ever change the direction at the very beginning, but functions are supposed to be generic. So this is another solution. It does the exact same thing. It might be clearer to you. What we could also do, let me clear this up. So another solution is let's do x equals active x coordinate and y equals this. And then we can do y while y is greater than ground level, active apple dot go to x comma y1. Oh no. What we do is y equals 1, and then come over here and do this. And this will do the exact same thing. This basically makes the code look a little neater because I'm storing these variables as something else. Personally, my first solution is probably how I would program it. If you want it to be better, you could do step equals 1, and then come over here and do step. That way, this if you want to change the speed at which it drops, you can come over here and just change the step variable. Now it's going to be changing by 5, and that was way too quick for me to even animate. Just do it 2. So this should be now moving twice as fast. So from this lesson, remember there's forward, there's right, there's left, there's go to. There's also set x and set y. So it might be better just to ignore the X altogether. So let's look at another alternative. So what we could do is while the Y coordinate is greater than ground level, I could do active apple dot Y set, and I want to reduce the Y coordinate by 1. So I could do Y coordinate minus 1. That crashes. So it says turtle object has no attribute called ySet. That is because it's supposed to be set Y, not ySet. So the function should be set Y. And note, that does the exact same thing. This is probably, now I'm looking at, is probably the preferred solution, or the most simplest. But notice there's multiple different ways of achieving the same thing. Everything I did it's the same. We could also, if we wanted to clean this up a little bit, we could do y equals this coordinate, and then we can come over here and have a step value. Step equals 1, and then we can replace this with y. Y minus equals. Actually, I'll even come over here and do this as -1, in which case we'll add step. And then put y here and comment out the old code. And you can see it falling down just the same. So multiple different ways of programming. You don't have to do y step. You can come over here and just hard code in that you -1. There's really no reason to change the step as it's only called in one place, and do something like that. To me, this function seems more powerful. This way of doing it. Not more powerful, more readable. Because it checks for its y coordinate and sees if it's greater than ground level. Then we set and change only the y coordinate to be 1 less than the current coordinate. So let's look at key presses. For your typing game to work, apples will fall from the tree whenever the user types the letter that is displayed on them. To do this, the program needs to detect the keys that users press. So being able to detect the keys a user presses is vital to providing additional interactivity between the user and the program. Let's explore how that works. So the program in the code editor draws the letter A, and when the user presses the A key, observe and run this. So it uses something called onKey press. So this onKey press function is a part of the screen. It takes a function. So it calls a function. And it also takes a different an argument, and it'll be the argument of what's done. Ooh, I really can't see that. Okay, so this W listen will sit here and listen for a key to be pressed. So it doesn't do anything, but if I press S, it won't do anything. But if I press A, it generates an A. So as soon as A is pressed, it calls this function. This function changes the color to blue and writes the letter A with this font. This is an event handler, or a listener. Pressing A is the event. And this is the, so look up proper terminology. Event handler. The event is the actual action of you doing something. There are things called event handlers, event listeners. This is an event listener. It's just basically a while loop. Has the user pressed A yet? No. Has the user pressed A yet? And it just repeats over and over and over again. Technically what it does, has the user done anything? Has the user pressed anything? Then it comes over here, and if you press the letter S, it does, alright, is there any event handler for S? This would be the event handler. And since there's nothing programmed for S, it won't do anything. So the onKeyPress function takes as its argument the name of a function and a string representation of the key that the program is to listen for. The function named has no parameters. Finally, note the call to listen method of the screen object when. Without that call, the screen does not know to be aware of key presses or mouse events. You may have seen events and event handlers before. I think technically this could be also called an event handler. So hold on, let's see. You may have seen event. So the draw and a function above is an example of event handler. So this is an event handler. It handles an event. These two functions are part of the event listener. So this would be considered part of the listener, and this would be the handler because it handles the event that occurs. So modify your program. I'm going to stop coding in. Modify your program to make your apple drop when the user presses the A key. Choose one of the following. So here it gives you two solutions. Add a function to your code that draws a white letter A over the middle of your apple before it drops to indicate to the user that they are supposed to type the letter A. You may want to reference the code above to see how the right function works. Call the function from your apple drawing function. Proceed to step 11 after this. We're already on 11. I think it means proceed to 12. Another way is add a function to your code that draws the letter A at the top of the screen to indicate that the user is supposed to type the letter A. We will be doing the harder one because I want the letters to be over the apple. I don't want you to. So basically, whenever you run your code, let me comment out drop apple. What I want is that on this apple, I want the letter A to be displayed. And when I hit the key A, I want both the letter and the apple to start falling down. In step 13, you will learn how to remove the letter and the apple from the screen. Don't worry about moving the letter when the apple drops. It says don't worry about it, but let's worry about it. I guess technically at this point you don't have to worry about right now. When you first code this, you don't have to worry about it. We just want to make sure that so usually when programming, you get it to do whatever you want first, and then you worry about fixing it later. So we usually do these actions one step at a time. So main goal at this step point is to just make the apple drop whenever you press A. But you need to indicate to a user when it's what letter to press. So if you're stuck on making the letter, the pair over the apple, I guess you can do easier right now, but you won't need to change it later. You may have noticed that your apple bounces around as you drew the letter A. To prevent this from happening, you can turn off tracing of your turtle's path as shown below. Mine never bounced. I had already programmed the correct way of doing it. To prevent, so you might have noticed that your apple bounces around. I get it. It's because whenever you draw the letter A. So let's come over here. So you can see, you can copy this. It needs to be white. Then we added event listener. Okay, this was my first attempt. So I got running a giant big A. Probably should move that down, but if I press A, it does nothing. So let me look at my solution. Now that's because still does nothing. Why does it do nothing? Ah, it was working correctly. So now when I press A, it drops down to the ground. I will say this. So when you use code like this, the function you pass it has to have no parameters. So I recommend, let me actually just create. So usually what happens, test.py. So usually what happens is we have, so let me just copy this. So we had this, so I showed you, we had this def drop apple function. Yes. So I showed you that I had this drop and it takes an active apple, right? It takes an apple, and then we dropped the apple. So whenever we want to press A, we want to make this apple drop, and we have a function that does that. Note, however, that the function we pass into onKey does not take any parameters. What you can do is, so we have a drop apple on A, so that when we press the letter A, it calls this function, and what this function can do is call drop apple with active apple like this. So this is a function wrapper. All it does is call another function. Since this function cannot have a parameter, we can make it call this function without a parameter, and this function just calls the other one. Make sense? Let me write the. What's a good B word? I know. So here's the code word of the day.